Hi, this is Janakareddy Dubbaka. NEET physics quick revision, that is formula revision. This is part 2 collisions. See here, elastic collision in 2 dimension. See here, this is a body of mass m1 moving with velocity u1 and it is collided with m2. After collision, m1 is moving in this direction and theta 1 is angle made with horizontal and m2 is moving in this direction with velocity v2 making angle theta 2. In this type of problems, we have to apply law of conservation of momentum along x direction and y direction. And also we can apply for law of conservation of kinetic energy, but only for elastic collision, not for inelastic collision. See here, initially along x direction, momentum is m1 u1. This is m1 u1. After that, m1 v1 resolved into in this direction m1 v1 cos theta 1, and this one also m2 v2 cos theta 2. This is along x direction. Along y direction, there is no momentum initial along y direction. Therefore, initial momentum 0. Final momentum m1 v1. This is cos theta 1 in this direction, sin theta 1. Therefore, m1 v1 sin theta 1. Therefore, upward direction is taken as positive and downward direction taken as negative. Therefore, m2 v2 minus m2 v2 cos sin theta 2. This we have to apply along x direction and y direction. This is case 1. See, in case 2, this is the surface. This is the normal drawn to the surface. If a body of mass m1 we are moving with velocity u1, which makes an angle theta with the normal. After collision, it rebounds in this direction. Here, this velocity can be resolved into two components. One is u cos theta, another one is u sin theta. Like that, here also after collision, its velocity is v. In this direction, v cos alpha, and this one is v sin pi, so cos pi and sin pi. This is angle of incidence, and this one is angle of reflection. Here, this is a common normal, and this is a common tangent. Velocities are only changes along common normal, but there is no changing along common tangent. Therefore, here this is velocity u sin theta along common tangent, and this one is v sin pi. These two are equal. Therefore, this is a formula for velocity after collision. V is equal to u into square root of sin square theta plus e square cos square theta. If it is elastic collision, E is equal to 1, sin square theta plus cos square theta is equal to 1. Therefore, V is equal to U. Therefore, in elastic collision, final velocity is equal to initial velocity. And tan pi is equal to tan theta by E. Here also, impulse is equal to change in momentum, that is mu cos theta into 1 plus E. And loss in kinetic energy, that is half mu square into 1 minus E square into cos square theta. These are the formulas for collision in 2 dimension case 2. See, here are some problems. A ball of mass m traveling with a velocity u hits another ball of mass 2m which is at rest. After impact, the first ball was found to be traveling at a velocity u by 2 in a direction perpendicular to original line of motion. Find the velocity and direction of motion of the second ball after impact. See, for this problem, you have to draw first diagram. See, this is before collision. This is mass m moving with velocity u, and this is mass 2m. It is at rest, means u2 0. After collision, the first body moves perpendicular to initial velocity direction. This is mass m with velocity u by 2. For example, second body mass 2m, its velocity not known, that is v, and here is theta. Here we have to find out what is the velocity of second body v and direction of motion. For this type of problems, we have to apply three things. First one, we have to apply momentum along x direction. Initial momentum along x direction is equal to final momentum along x direction. If you get the answer, stop there. If you are not getting the answer, and go for second step, apply law of conservation of momentum along y direction. If you get the answer, stop there. Otherwise, third one, if if it is elastic collision, we can apply law of conservation of kinetic energy. See, first one here, initial momentum along x direction is equal to final momentum along x direction. Initially, this body having only velocity, this one is 0. Therefore, momentum m into u plus 0. So, your final momentum, this body having the velocity only along y direction, there is no momentum along x direction. But this body having momentum v theta, therefore, momentum is 2mv. If you resolve along x direction, 2mv cos theta. Therefore, this becomes 2mv cos theta. Therefore, here m gets cancelled. U is equal to 2v cos theta. It is equation number 1. See, from this equation we cannot get the answer. Then go for further one, momentum along y direction. See here, P initial y direction is equal to P final y direction. Initially there is no momentum along y direction, therefore initial momentum is 0. And final momentum, here it is moving mu by 2, mu by 2, mu by 2, it is taken as plus, and this one 2mv here cos theta, this one is 2mv sin theta, downward direction minus, therefore this becomes minus 2mv sin theta. From this, mu by 2 is equal to 2mv sin theta, m gets cancelled, u by 2 is equal to 2v sin theta. Therefore, here this is equation number 2. See, from these two equations we can find out velocity v and also u. See, if you square the equation 1 and the equation 2, add these two, that implies this is u square, and here is u by 2 means u square by 4. This is 2v cos theta means 4v square cos square theta. Here also 2v sin theta, 4v square sin square theta. Here this becomes 5u square by 4. Here 4v square common. This becomes cos square theta plus sin square theta. Therefore, cos square theta plus sin square theta is 1. Therefore, 5u square by 4 is equal to 4v square. From this, v square is equal to 5u square by 16. Therefore, v is equal to root 5u by 4. This is the velocity of second body. Then its angle means if you divide 2 divided by 1, that implies this is u by 2, by 1 is u. This becomes 2v sin theta by 2v cos theta, 2v gets cancelled, u gets cancelled. Therefore, this becomes 1 by 2, and this is tan theta. Tan theta is equal to 1 by 2. Therefore, theta is equal to tan inverse 1 by 2. This is the direction of second body. Like that, see here. On a friction surface, a block mass m moving at a speed v collides elastic with another block of same mass m. Sorry, it is frictionless surface. Same mass m, which is initially at rest. After collision, the first block move at an angle theta to initial direction and a speed v by 3. The second block speed after collision. See here. First, we have to draw that diagram. A block of mass m moving with a speed v. This is the block of mass m moving with a speed v. Collides elastic with another block of mass, same mass, which is initially at rest. Therefore, its velocity is equal to 0. After collision, the first block moves at an angle theta to initial direction and has speed v by 3. See, first block moves m. This is velocity v by 3. This angle is theta. And the second block speed after collision. here I am taking, for example, this body mass m moving with velocity v dash. This angle I am taking theta 1, this one is theta 2. Here, this is elastic collision. We have to find out only velocity, not direction. For that, we can directly apply law of conservation of kinetic energy. See here, this is elastic collision. We have to apply this law only for elastic collision. See, total kinetic energy before collision here is half mv square. This one is 0. And for this one, kinetic energy does not depend on direction. Half m v by 3 whole square. And this one, half m v dash square. Therefore, here 1 by 2m, 1 by 2m, 1 by 2m cancel. Therefore, v square is equal to v square by 9 plus v dash square. Therefore, v dash square is equal to v square minus v square by 9. This is 8v square by 9. Therefore, v dash is equal to 2 root 2 v by 3. This is the velocity. Here, one important note point, that is, if m1 is equal to m2 and u2 is equal to 0, second body is at rest, then theta 1 plus theta 2 is equal to 90 degrees. So very, very important one. If you want to find out the direction, if one angle is given, we can find out other angle. Therefore, if m1 is equal to m2 and u2 is equal to 0, u2 is equal to 0 means second body is at rest, then here this theta 1 plus theta 2 is equal to 90 degrees. See, for this two-dimensional problems, we have to apply 3 steps. In step 1, we have to conserve momentum along x direction. Second one, we have to conserve momentum along y direction. And third one, we can conserve kinetic energy, but only for elastic collision, not for inelastic collision. This is lecture 2 from collision. It is a two-dimensional collision. Thank you.